Hello and welcome to the OpenSAP course Writing Testable Code for ABAP. My name is Jürgen Heimann.
And my name is Thomas Hammer.
And together we'll lead you through this course and the content. And this week, in the first week, we'll look at ABAP unit testing. But before we do that, we want to give you an overview and motivation why this topic is even important and why you should care. But before we do that, let's look at the whole course overview. So we first start with a motivation part where we explain, again, what are the benefits of doing this. Then follows a unit where ABAP unit is explained in the sense of how is the syntax and so forth. After that, test-driven development and pair programming as a way to do development together. And then
we do test isolation, the most important topic of the whole course. And then we also tell you something about how to deal with legacy code. And in the end, continuous integration, so how to execute everything you wrote and learned in the training frequently so that you really get a benefit out of it. And here on the right, you see this scale. And this should symbolize that writing testable code and writing effective and efficient automated tests, they go together. So you cannot have one without the other. So our goal is to have tests, and we only can have tests if we have testable code.
all right, here a well-known quote from Miško Evry, a guy at Google who has been promoting this topic there for a couple of years. You can find him on the internet. And he says, there are no tricks to writing tests, there are only tricks to writing testable codes. And what this means is that the real difficulty is in writing testable code, and when you do that, then writing tests becomes easier, or actually in many cases only really possible certain things. So let's start and discuss why do we even care, because you may wonder, why should I do this course? You know, who cares about testable code? Well, you want to have tests, you want to have automated tests, because to keep doing manual tests all the time for your software is completely impossible as far as the effort that it takes, and you want to be able to do that faster. So the trouble is, if you look on the right there, you have a typical system where you have big modules, and then you have one little piece, the blue box with the X that you care about, and you want to test whatever is in this box. So maybe you added a new case or some formula in there that you want to test if it works right now. If you test that as part of the whole system, you have to start at the top and go through modules, whatever the way is to get there, and then you will see, oh, I also have to do some setup for this thing to run. So you need some data, and you have dependencies even to lower modules. And that has a lot of disadvantages. So number one is you can build this kind of test only at the end of development when everything is done. And then the mistake that you may have made is weeks and weeks ago, and you don't even know and remember things anymore. It's very complex in setup. The tests will run long. They're slow because they have to go through all the layers. And when something goes wrong, and this test that is supposed to test what's in the box, it could be anywhere on the way going there, but also in the dependencies below, and you have to, it's a high effort to figure out what was really wrong. And that's what's called fragile tests. They depend on many things, and they're not supposed to depend on anything except the logic in your code. And because of all this, the tests are very high maintenance, and that's a bad thing.
And we have to mention one thing. There's an advantage, let's be fair. Mm-hmm. And the advantage is that these tests are running in the real environment. So there is no,
that's true.
No mocking, no test doubling. So everything is real. But this comes with a price, and you just mentioned the price. And the price is very high.
Yeah. So there must be a real test as an integrated test, but it's not a good way to test the functionality on a detail level. And that leads maybe to another analogy that is maybe easy to understand. Just imagine if you would put an airplane together, all the pieces, and put it all together, put it on the runway, and just try if it flies without having even tested any part by itself. Never have turned on the computer, never have checked if the engine even starts. You would never do that. It's completely crazy. But in a way, this is what you do when you say you write a whole bunch of software and thousands and thousands of lines, and then in the end, only when you are done with all the layers, you can start testing it. And then everything that goes wrong underneath, you have to kind of deal with at the same time. So that's a very bad thing, and that makes it slow, and so it makes it hard to find individual errors just like that. So we come to the overview and the motivation for unit tests, and this is something that actually is the focus of the course, not just test automation, but unit tests, and because they have very certain advantages when you want to focus on a small part. And basically, if you look on the right-hand side, the key statement there is that the unit test is right next to the code that you want to test. So it's not at the top of the system, has to go through all the layers, but it's actually it's right next to it. It tests what it's, basically what you build the test is right next to it, and they actually are even transported together. And the advantages are, number one, it can be built during development, and actually it should be. So you do the test immediately and you see, oh, all the cases work. It's isolated from the environment, so you don't need the whole stuff around. And fast because of it, you can do typically thousands of these tests per second. And the error analysis is easy because if something goes wrong, the tests point exactly to the place where it goes wrong. And therefore it is stable, it is not dependent on the environment, and very low maintenance. And of course the disadvantages, like you said.
Yeah, there are some things which are simulated, and so even if the real part which is simulated changes, your unit test will not discover something like that. But still it would test what it's made for, and that is the unit. And that's the main point.
Right. So of course, if you want to do this thing in isolation, it's still embedded in its module, and it needs some kind of isolation and simulation of the environment to be able to run this thing. Mm-hmm. And that again has advantages and disadvantages that we'll be talking about. So to be able to do this, you need decoupling. And this is the thing between the test, the code that you have there that you want to test, and its environment, because only the decoupled product code enables you to write your tests isolated from the environment. So basically you can plug in the dependencies and simulate what it normally would depend on. Right? And one thing that is needed to do that is refactoring. Refactoring is the process, is a quote from Martin Fowler, another famous guy in the computer science world. Refactoring is the process of changing a software system in a way that it does not alter the behavior, but only the internal structure. So you improve the code, but not you change the behavior. And one element of this changing is that you cut those dependencies and that you make this somehow switchable and controllable. And this is a big part of what we're going to learn. And finally, clean code is something you need for tests, but not in a way of a cosmetic way, but in a way that it's well structured. Well structured code is also easily testable. And there we have our picture again.
Yeah, and maybe one addition to the clean code. Yeah, it's not only about the looks, but it's also about the looks. Mm-hmm. Because if you have clean code, meaning it's very structured, very well written, all the indentation is done correctly, it's easier to understand. And if the code is easier to understand, it's also easier to test because you understand it. You need to understand the code in order to test it. So if you come to, that's the legacy part we will see later, if you come to code which you yourself did not write, but someone else did, and that someone else wrote very clean code, it's easier to understand. It's better to write. It's easier for you to write tests in that case, and so it's the main point. We will not focus that much here in the training, but you should during development.
Mm-hmm. Yeah. Okay. Another interesting quote from Gerhard Messaus. He wrote this book, X-Unit Test Patterns, also another book that you should have. And in a talk that he gave at SAP, he says it many times, but he said it also there, is if the tests are good, then the product code is probably good enough. If tests are bad or not existing, then all hope is lost. Now what that means is that often you do have an existing system that has grown over years many times. And you can't just go in there and say, oh, I have a new idea on how to restructure things. I'll have unit tests everywhere. You cannot do that. You cannot afford it. So for that, it's better to have a test on the outset that basically captures the behavior of this code and safeguards that it doesn't break. And so sometimes, in that sense, a good test is even more important than good product code, at least for existing code. Now, for new code, of course, you want to do it the other way around and write the new tests and everything first. But I think it's an interesting way to see that tests are not something you just do on the side if you have time and it doesn't matter so much. A good structured and clean code for tests is almost as important as, actually I would say it's as important as product code structure.
Yeah.
Yeah.
If not more important.
And yeah.
And not all hope is lost is a very strong statement, but it's kind of true, sadly. Yeah.
Or the hope is not, if you want to get out of this hole, you have to invest a lot of time.
Yeah.
That's the point. And one more point, why is it important to refactor test code just as much, is because if you do this, writing the next test becomes cheaper and cheaper and better and more stable. And that's, of course, is also important. This is going to be also something we'll be teaching you. So this diagram here shows how those things work together. You probably have some experience with automated tests, and often this starts at the system level or maybe a little lower integration, some big component. But this pyramid shows the ideal way to spend your effort and also spend basically your code coverage targets. And that is that on the unit test level, you want to really cover the code, which means 90% plus code coverage of unit tests. And then going up, you do less, because on the unit level, you focus on the functionality. There you can really test all logical cases that are kind of hidden in the code and the behavior. And then going up, you only focus on, is the data flow correct? You don't repeat the complexity of the behavior on the higher levels, because that gives you this combinatorial explosion that you cannot deal with all the combinations anymore. And then finally, if you have a UI where you do some usability tests and some exploratory testing, it's a good thing, and that's manual, but all the other things are supposed to be automated. And what does it give you, this automation?
Yeah, it gives you the confidence, and the confidence that you don't do the wrong thing, that you're on the right track, and that you don't add new errors into your code while developing. And there is one more thing I would like to add, and that is when you are writing higher level tests like the UI testing and the integration tests, it's not always possible to test all the combinations which the underlying functionality is offering. And there you will have gaps, and that's the big benefit of the unit test. They are so close to the interface of the unit that they can test all the combinations. So if your current UI functionality, for example, is always calling the underlying functionality in a certain way, and then all your tests might pass. But then there is this new UI functionality or the change in UI functionality, and suddenly the underlying code is called a little bit different than before, and then it might break because no one tested that before. Mm-hmm. But if you have your unit tests in place, then you should be safe, because you can test and you should test it beforehand, even though your UI functionality is not using it yet.
Right. So when you do a unit test, you focus on what's your code under test, and you try really to exercise all possible cases. And especially also the error cases, because that's otherwise very hard to do. If you want to exercise and test error handling, it's typically not possible if you do integrated tests, because how can you simulate or create all kinds of errors in other modules? That's really, really bad.
And a lot of errors are hidden in the error handling. Mm-hmm. And here you have the tool to do it, to do the testing for that.
Right. So finally, the last point of overview and motivation is really twofold. And one is for the developer. It's just more fun to develop that way, right? You would say. And why is it more fun? Well, you spend a lot less time in finding your own bugs and debugging and wondering what is going on. And you can have more time for feature development, because that's in the end what developers like to do, right?
And it's also very satisfying if you do something and your tests tell you yes, you did not introduce something which was wrong, but we are still alive, so the test is still functioning and no error was introduced. So that's this motivation you get from your own tests, and that's fun.
Mm-hmm.
Yeah.
Yeah. Another thing is that what's indicated on the right is actually something that has to do with like almost development efficiency or productivity, if you will. If you look at the bigger picture and you introduce a lot of bugs that are hard to find, and this just happens. And if they go out to the customer or to later stages in development, it's much more difficult to find in analysis terms, but also in fixing them. And so this creates often a whole ton of work that is really not pleasant. And it also is, it hurts you in the sense that you cannot write features, more, faster. And so if you do this unit testing, test-driven development, the bug rate coming out of the development stage is much lower. It gives you much less work later on, and it gives you more time then to work on the next thing. So that's good for you as a developer, and of course also for the managers who always wonder, why is it taking so long?
Okay, and that was it for our first unit. And in the next unit, we will dive into the basics of ABAP unit, the syntax of ABAP unit, and hope to see you then.
See you then.